In this video, we'll look at one-to-one functions. Recall that to be a function, each input in the domain of f, so that's usually an x value, can only correspond to one output. We usually think of y as our output. So for any x in the domain, there's only one y. We use the vertical line test to determine if a graph is a function. The graph is a function if and only if no vertical line can intersect the graph in more than one point. So we did all of that when we were first introduced to functions back in the first unit. Now we're looking at whether or not a function f is one-to-one. So this is new. One-to-one means that each output, so each output is the y, corresponds to only one input in the domain of the function. So in other words, for any y in the range, there's only one x. This means that if a function is one-to-one, there cannot be any repeated x or y values. If there are repeated x values, it would not be a function. And if there are repeated y values, it would not be one-to-one. To determine if a function is one-to-one, we can use the horizontal line test, which says that a function is one-to-one if no horizontal line can intersect the graph of the function in more than one point. So let's look at just a few examples really quickly. So say I had this graph that was a cubic, so y equals x cubed. This passes the vertical line test because no matter where I draw a vertical line, it's only going to touch the graph in one spot. And it also passes the horizontal line test because anywhere I draw a horizontal line, it would only touch the graph in one spot. So this is an example of a one-to-one function. Now, on the other hand, let's say I had a parabola. So let's say I had a graph that looks like this. Now, this passes the vertical line test because anywhere I draw a vertical line, it will only touch the graph at one spot. So this one is a function. However, if I drew a horizontal line, you can see it would touch the graph in more than one spot. So this one would not be one-to-one. So a graph can be a function without being one-to-one. And what we're just checking for is whether or not each y value corresponds to only one x value. You can see that this y value, whatever it is, it corresponds to two different x values, and that's why the horizontal line would touch the graph in more than one spot. Let's look at these graphs and determine if each one of the functions is one-to-one by using the horizontal line test. So that's always going to be our test for a graph to see whether it's one-to-one. Okay, so let's look at this first one. We have some form of cubic function that shifted downward below the x-axis a little bit. So if we drew a horizontal line anywhere on that graph, it only touches the graph at one spot. Even here, that horizontal line only touches the graph at one spot. Here as well. So no matter where I draw my horizontal line, it only touches the graph once at one spot. And so this one is going to be one-to-one because each y value only corresponds to one x value. You can look at this y value only corresponds to that single x value. This y value only corresponds to that single x value. And this y value only corresponds to a single x value. And that would be true for any y value on this curve. Let's look at the next one. So the problem that I see might be right here when y is 0, but because this is a hollow dot, that means that it is not included. That y value is actually not included on the graph, that ordered pair, I should say. So even if I drew a horizontal line right here, we would consider it to only be touching the graph at the filled in dot. And so this one is also 1-to-1. It passes the horizontal line test because that's a hollow dot. And so a horizontal line drawn right here, the only intersection with the graph would be at that filled in one. All right, let's look at this discrete graph, meaning it's just a bunch of dots. So we want to know if it passes the horizontal line test. So I draw a horizontal line where I think I might have a problem, and I see that that horizontal line hits the graph, in this case, a discrete graph, a cluster of points. It hits the graph at 2 separate points. And so this one would not be 1-to-1. So if any horizontal line hits the graph at more than one spot, it would not be 1-to-1. We also have a problem here at y equals 1 because the horizontal line hits the graph at x equals 1 and at x equals 5. All right, and we can see a parabola. We already looked at a parabola on the previous slide. If we draw a horizontal line, it hits the graph at more than one spot. And so we know that there's at least one y value, in this case, many y values, that are mapped to by more than one x value. So the horizontal line test tells us that there's a y value that has more than one corresponding x value. And by definition, that would make the graph not 1-to-1. Now, in the next video, we're going to look at inverse functions, and a graph has to be 1-to-1 in order to have an inverse. So that's why we're focusing on that here, so that we'll be able to tell whether a function or graph is 1-to-1.